Now we are going to see one of the important constant in Bohr atom model is fine structure constant. That fine structure constant that is represented by the letter alpha. Okay. Now I am going to write the formula for alpha. There are two formulae. The first formula is V1. What is V1? V1 means velocity of the electron in the first orbit in any element, in any atom. Are you clear? Velocity of the electron in the first orbit divided by speed of light. Are you clear? This is the formula. Alpha is equal to V1 divided by C. This is one of the formulae to calculate fine structure constant. This is equivalent to E square divided by 2 epsilon naught Hc. This is another formula. So this is obtained from some other derivation. So you have to understand, you have to by heart both the two. So fine structure constant alpha is equal to V1 divided by C, E square divided by 2 epsilon naught Hc. Here to define the fine structure constant, you have to use this expression. So how to define the fine structure constant? That is nothing but that is a ratio of speed of electron in the Bohr orbit, that is in the first orbit, to the speed of light in the vacuum. So this is the definition to be written for fine structure constant. Now I will substitute the values. E value, that is nothing but 1.6 into 10 to the power of minus 19 whole square, E square, no, therefore whole square, whole divided by 2 into epsilon naught value 8.854 into 10 to the power of minus 12. So this is the value of epsilon naught into Planck's constant 6.6 into 10 to the power of minus 34 into C value, speed of light 3 into 10 to the power of 8. So all values are substituted here. After substitution, after simplification, you will get the answer as 1 divided by 137. So this is the value of alpha. So this is the value of alpha, that is fine structure constant. It's a dimensionless number. It does not have any unit, it does not have any unit and dimension. That's why this number is called dimensionless number. Okay. Now we can use this alpha to calculate the velocity of the electron in all the orbits in hydrogen atom. Not only in hydrogen, in any orbit, in any element, the velocity of electron can be calculated. So this number is very important one. Are you clear? By using this number, we are able to calculate the speed of the electron in any orbit, in any atom. Okay. Now we are going to see how the velocity of the electron in different orbits in hydrogen atom can be calculated by using fine structure constant. Fine structure constant alpha, its value is how much? 1 by 137. Already we have calculated the value of alpha fine structure constant. By using this alpha, we are able to calculate the velocity of the electron in different orbits in hydrogen atom. Here you have to follow this formula. Vn, velocity of electron in any orbit, Vn is equal to alpha C Z whole divided by n can be written. Here alpha is fine structure constant, C is the speed of light, Z is nothing but atomic number, n is the principal quantum number of the orbit. Are you clear? So here the variable is n, alpha is constant, C is constant. In the case of hydrogen atom, Z is equal to 1. So this formula can be slightly altered, so according to the hydrogen atom. So in the case of hydrogen atom, Z value will be equal to 1. So how this formula can be altered? Vn is equal to alpha C, instead of Z I can write 1. After substitution you can write like this. Here alpha value is 1 by 137 and C value is 3 into 10 to the power of 8 meter per second. Depends on the principal quantum number, the velocity will change. Now I am going to simplify this formula. 3 divided by 137 value is 0.0218 into 10 to the power of 8 can be written. After simplification, this value, this one becomes 2.18 into 10 to the power of 6. So this factor you will get divided by whole divided by n can be written. So the formula, final formula is Vn is equal to 2.18 into 10 to the power of 6 whole divided by n is a formula to calculate the velocity of the electron in different orbits in the case of hydrogen atom specifically. So finally we can use the unit meter per second. Now I am going to calculate the velocity of the electron in the first orbit. Substitute n is equal to 1, V1 is equal to 2.18 into 10 to the power of 6 whole divided by 1. Its answer is 2.18 into 10 to the power of 6 meter per second. This is the speed of the electron in the first orbit of the hydrogen atom. Now I am going to calculate the speed of the electron in the second orbit. So what to be done? V2 is equal to same formula 2.18 into 10 to the power of 6 whole divided by 2. Its answer is half of this 1.09 into 10 to the power of 6 meter per second. Now we are going to calculate the speed of the electron in the third orbit. N is equal to 3. V3 is equal to same formula 2.18 into 10 to the power of 6 whole divided by 3. If it is divided by 3, you will get 0.73 into 10 to the power of 6 meter per second. So like that we have calculated the speed of the electron in first 3 orbits. Now we have to compare all the 3 speed of electrons in 3 different orbits. Just you compare. After comparing, what would be the conclusion? In the first orbit, the electron, it is revolving with the greatest speed. Its speed is tremendous. Compared to the first orbit electron, the second orbit electron, it is moving little bit slower. Compared to the second one, the third orbit electron is still it is revolving in a lower speed. Therefore, after comparing we can write the velocity of the electron in the first orbit, it is greater than velocity of the electron in the second orbit, that is greater than which one? The velocity of the electron in the third orbit. So if you move in the towards outward direction, that is when n increases, the velocity of the electron decreases. When n increases, velocity of the electron decreases. So that is a conclusion. Mainly the purpose of solving this problem is the velocity is calculated with the help of the constant called fine structure constant. By using the constant fine structure constant, we have calculated the speed of the electron in any orbit. Okay. So be thorough with this. If any problem is asked, you can solve this. This problem is done only in the case of hydrogen atom. Okay. Thank you.